In the world of Java, where multiple threads often run parallel, synchronization is the key to maintain order in the chaos. Today we are going to understand how Java helps us manage concurrent processes safely and efficiently. So, hello everyone, my name is Sujal Roy. I am currently pursuing BCA from CMH Professional College and I am currently in third semester batch 1. So, by my earlier phase, you can pretty much understand what we are going to talk about today. Yes, it is synchronization in Java. So, before we learn about the synchronization, first we have to understand what is multi-threading. Because synchronization always apply in the multi-threaded environment. So, what is multi-threading? Multi-threading in Java allows multiple parts of the program run concurrently, often called threads. Making efficient use of CPU resources, especially in multi-core system. In the multi-threaded environment, there are some conditions called race conditions. So to prevent from them, or we simply can say that to prevent fight between two or more threads on a single resource, we use synchronization. So what is synchronization? So, synchronization in Java is a mechanism ensures that only one thread accesses a particular resource at a time, and it prevents conditions just like I before mentioned, like race condition, and it also prevents data inconsistency and unexpected behavior of a program. So, how does synchronization work in Java? So, Java uses a lock or monitor to control access to the synchronized block or method. When one thread is executing that synchronized block or method, all other threads that trying to gain access of that block or method, the Java send that thread in a block state. Where it wait until the lock releases, and after the lock releases, Java send notification to all the threads to wait and complete their task. So, let us understand with a real life example. Imagine two people sharing a single account, and they are trying to withdraw money from it. So without synchronization, they both can withdraw money before the balance updates. So it will cause overdraft. So let's see this in a code. This is our code. So here I created a class named bank account, and I've created inside this class there is a private method which is a balance. So in this method we have used a synchronized method. Here whenever a thread tries to gain access in this block, the other thread will have to wait. So in this synchronized block, I have first mentioned that what thread is going to access it. Then I have compared that amount is available or not. And here I have simulate delay, which is somewhat a delay that we are facing whenever we withdraw money from the bank. So it is my synchronized method inside a common resource. So इसको और सही करने के लिए, so here I created a thread we have created a class which I extend with a thread. Here inside I have a one one bank account reference variable and the constructor where I have initialized it, and there is my bank simulation public class where I have written void main method. So yeah, there we have created our two threads which are going to access this common resource, and I have started them. So first when first thread starts, the control will transfer there. So in there it going to access the synchronize method, and this will block the another thread which started after it, and it will block it when first thread processing its data, the other thread is in block state. Let's see the output. The code is successfully compiled. Let's see the output. Here, the first thread access that common resource, and Alice is our thread which is trying to withdraw 700. So the next line will be the Alice withdrawing the money. In that state, the Bob is currently in block state. So after the Alice completed its withdrawal, Bob is notified that Alice has completed. After that, Bob comes in and it is trying to withdraw 700, but because Alice already withdrawed 700, so the balance isn't sufficient. So there is a method called insufficient balance for Bob. If we didn't use synchronization in this, both of them going to withdraw money at the same time before the balance updates. Let's see also that if just I deleted synchronized here and recompile my code and run it here, you can see that both of them are trying to withdraw, and they both withdrawed. Here we can see that the remaining balance is updated after the withdrawal, so it will be get in minus. It is caused the over withdrawal problem without synchronization. So apply synchronization in Java. We have two ways. First, that I have discussed, that there is a synchronized method. In the synchronized method, all of the code written inside that method will be blocked during the execution of the one thread. And there is one called, and I had another example of a simple table printing code. Here I have used the synchronized block. Synchronized block does only the critical codes inside a method, and it doesn't block overall the method. So that's all from my side. Anyone having any question, please ask. Question, please ask. Shivam.
What is the purpose of this keyword in line number 3?
So we have used synchronized block here. This keyword is showing that we have to block this object instance. We have to block this keyword.
If there is a line of code outside of the synchronized block, will it access by thread? If there is a line of code outside of the synchronized block in the same function, will that line of code be accessed by both threads simultaneously?
Yes, this is the main purpose of this block, because we have to write only critical lines in it. Another line that are not that critical, the both of them access it simultaneously inside this method. Only this block will be blocked during the execution. Only one thread accesses at a time.
Please continue.
Demo.
Write a system.out.println outside of the synchronized block.
Okay.
And then call the printable function by both the threads.
Is it okay? Successfully compiled. Cannot on the Java developer. Sorry, my bad. Synchronize.
But the system.out.println high should be called every time by both the thread. It is called only once. Why? It is outside of synchronized block.
Yes.
Then why not it is called many times?
You have to see the flow of execution. If I have started T1, so it will go here and doing this work. The 5 table you will see.
And in the meantime, the thread T2 could access the system.out.println.
No, because we have the flow of execution. The flow of execution will break if it access directly.
So that means if just adding a synchronized block in any function, each thread will going to block state.
Yes, for this particular instance, because
Then what is the difference between synchronized adding function and then block?
so method in the method, if I method this, the overall will have to the overall code will have to blocked. So if the system.out.println will so that it is outside the synchronized block, so it will have this delay that I have entered here. There is no delay to access this, but there is a delay inside my synchronized block. So there is a delay between accessing it. Here it is accessed directly and very fast by both of the threads.
Anybody else has any question? Yeah, it was a really very nice presentation and very nice explanation. So I can treat it as a very small minor project in Java. So I would request everyone to prepare your own minor project implementing certain concept in Java and present it in front of your friends in the class. Okay, thank you very much for having a wonderful presentation.